So we are ready to go. And we're just going to be taking a look at the solution of a pair of simultaneous equations. And the pair of simultaneous equations, of course, has a linear equation and one that is not linear. So this one might well be parabolic and this one is linear. And as a matter of fact, while solving this equation, we will have two sets of solutions. Now, the particular system that we have here gives us quite a few different opportunities to solve, as a matter of fact. And we may solve this pair of simultaneous equation. Generally, when we are solving a pair of simultaneous equation, of which one is linear and the other is nonlinear, generally the approach that we take is by substitution. But if we look a little bit closer, we will see that we might use the method of elimination in solving that pair of simultaneous equation. And let's go straight ahead and use elimination. So if we are using elimination, we may say that begin by saying equation 1 plus equation 2. Reason being is that we have this negative y here and this positive y here. So when we are adding on this right hand side, the y's will be eliminated. So we'll have here x squared plus x on the left hand side. So we'll have x squared plus x right there. Also, when we add these, the y's will be eliminated. And then we'll have 4 plus 2, which is equal to 6. So really, we should have that equal to 6. However, we will eventually have to convert this into a trinomial by ensuring that all non-zero terms are on the left-hand side. So we will eliminate this 6 by subtraction. So we will have a negative 6 there, and of course we will have 0 there. So here we have our trinomial, and we may say what two numbers multiply to give a negative 6 and add to give a positive 1, because a positive 1 is the coefficient of this term in x. So factorizing our trinomial, we'll have x plus 3, x minus 2. Therefore, x is equal to negative 3 or x is equal to 2. And we're going to put that into which equation? We're going to put that, these values of x, into the simpler equation, which is equation 2. So we'll put that into equation 2. Therefore, in equation 2, where we see x, we put a negative 3. And negative 3 will go there, is equal to y plus 2. And that will result in, as a matter of fact, to give ourselves space, we could do it like this. X is negative 3, so negative 3 is equal to y plus 2. And we can see that we need to eliminate this positive 2 by subtracting 2, or by subtraction. So we'll have y is equal to negative 5. On the other hand, if x is equal to 2, what happens? Here we see x, we put 2 is equal to y plus 2. It's clear here that y is equal to 0. Y is equal to 0. Y is added to 2 and the result is 2. So we know that y is equal to 0 there. So we may say when x is equal to negative 3, y is equal to without solving, we may demonstrate, that if we might take other approaches to the problem and still arrive at the correct answer. And we'll just go straight ahead and not be exhaustive about it, but to demonstrate that when we use, say, another substitution method, we might use another substitution method, and in this substitution method, we might take equation 1. From equation 1, what do we say from equation 1? Y. So if we transpose this, we're going to get y is equal to 4 minus x squared. So y is equal to 4 minus x squared. Then, from 2, what do we say? Y is equal to x minus 2. Y is equal to x minus 2. So we have y is equal to, and we have y is equal to. So if both of these are equal to y, then they are equal to each other. So we might have x minus 2 must be equal to 4 minus x squared. So x minus 2 is equal to 4 minus x squared. And we can express this as a trinomial with all of those non-zero terms on the left-hand side. So we will have, for this one, we'll have an x squared there. We have the x will remain. And of course, we have a negative 2 here and a positive 4. We will eliminate the positive 4 from this side by subtraction. So we will have negative 2 minus 4, which is equal to negative 6. And then that is equal to 0. If we take a note of that, we'll see that it is equal to this. It's the same equation that we have. So if we continue to solve, we're going to get the same values for x, and then the equation will be solved in the same manner. So in this case, what we have done is express each equation y in terms of x, and then of course y is equal to, therefore these two must be equal, and then when we put them together, we get the same equation that we have right there. We may also take another approach, and this approach is like this one. Let me see if I can write that in red. X squared is equal to 4 minus y. We have x squared is equal to 4 minus y, and x is equal to y plus 2. So this is x squared, this is x. So if we square this, we should get this. So we may write that as square this y plus 2 all squared, and that is equal to 4 minus y. Sure, on this occasion, the equation will be in terms of y. But it doesn't matter. Let us continue and see what will happen. We have, of course, students know how to manipulate the perfect square quite easily. So we should have y squared plus 4y plus 4, and that is equal to 4 minus y. What will happen? Y squared will return. These 4's will take care of each other. We'll have a cancelling effect on each other. And then what we have is a negative y here that we will eliminate by addition. Therefore, we'll have a positive 5y there. Then when we are through, we'll have y as a common factor, then y plus 5 equals 0. So y is equal to 0 or negative 5 in that particular case. Now, look at this. Y is equal to negative 5, y is equal to 0. So there we have, this solution is being reflected here. So we know that we are consistent, and any of these methods may be used to solve that equation. So we may, at the equations eliminating the y, that is the first one, then we may write each equation in terms of y and then equate the right hand sides, or we may say that this is x squared and this is x. So if we square this, we should get this. That's another approach that we have taken, and this is our solution. Now we have another system of equations, and this system we are not going to solve at all. So we're going to just write that as x plus y is equal to 5 and xy is equal to 6. Now what do we know? We do not have to go at length to prove anything in order to solve this equation. Maybe we could put the steps in to substantiate our answer. But no doubt, we do not have to go through all of that in order to see that if we have two numbers added together and the result is 5, and then we have two numbers, those same two numbers multiplied together and the result is 6, then of course the numbers are 2 and 3. Also, by the looks of this, we know that one of the equations is linear and the other is nonlinear, which might, but not necessarily, result in a quadratic equation that has two sets of solutions. So we know that when x is equal to, y is equal to. When x is equal to, y is equal to. So when x is equal to 2, y is equal to 3. And when x is equal to 3, y is equal to 2. So that's the solution of this system of equations. As a matter of fact, it should look like this. One equation will go like this one. Of course, this same one will have another part down here. Xy is equal to 6 will have another section here. But the focus is not on this section because we have x plus y is equal to 5. And x plus y is equal to 5 is a line that will go somewhat like this. So the line will cross about there and about there. So this point would be 2, 3, and this one will be 3, 2. And this line will be x plus y is equal to 5, will cross 5 here, and cross at 5 there. And then the other one, this is the curve. xy is equal to 6. And the curve will cross the line 2 places. And that is how we have 2 sets of solution. Now, we'll move merely to another, I think that is this one, and see what we make of it. Maybe I'm not going to go to this one as yet. We have quite a few of them to solve, and I am looking right onto that. Right. We have solved this one already, and we have it right here. So we move on to another one. Of course, we are attempting to go through the odd numbers. Hopefully, we do not have any type of graphical errors, so our systems will be clear cut. So the other one, I hope, is okay. So we have for that one, number 3, x plus 1 is equal to 2y. X plus 1 is equal to 2y. And x squared minus 3y is equal to 4. X squared minus 3y is equal to 4. So that is your equation 1, and that is your equation 2. Now, we might just search for quite a few different ways to solve this equation. And as a matter of fact, I think that I've seen the one that will work out to be, as a matter of fact, the one that will work out quite quickly. Now, let us examine this. We may write y y in terms of x. We may do that. But here we have 2y, so we will have to divide by 2. Here we have 3y, so we will have to divide by 3. What else do we say then? We could not add the equations in order to eliminate anything, so elimination will not work. We may just take from one equation and substitute into the other. Let's say x is equal to 2y minus 1 and put it right here. Let's try that. X is equal to, I'm going to write that, from equation 1, x is equal to 2y minus 1, and that is your equation 3. That you're going to put into equation 2. So where you see x, you put 2 minus y. So 2 minus y, let's write it again, 2y minus 1 all squared minus 3y is equal to 4. So that's what the equation looks like. So 2y minus 1 all squared is equal to 4. So we're going to do this perfect square. 4y squared minus 4y minus 1 minus 3y minus 4 is equal to 0. As I was saying before, let's see if this system will work or will give us values that are easy to work with. So we'll have 4y squared minus 7y minus 5 is equal to 0. Let's go again. This should have been a positive 1. So we still have our negative 7y. This should have been a positive 1. Then 1 minus 4, with that will give us a negative 3. That should work. Or should it? So we have 4y squared minus 7y minus 3 is equal to 0. And as a matter of fact, I was a little bit skeptical about the coefficient here, especially the 2y is equal to x plus 1. So I'll take a second look at this and see where the result actually did not add up. So let's go again. First of all, I'm going to make sure that we have the correct thing. X plus y, x plus 1 is equal to 2y, and of course x squared minus 3y is equal to 4. So we have x is equal to 2y minus 1. So we have x squared minus 3y is equal to 4. So we have 2y minus 1 all squared minus 3y is what we have there is equal to 4. So when we expand this perfect square, we'll get 4y squared minus 4y plus 1 minus 3y, of course, then minus 4 is equal to 0. So 4y squared minus 7y minus 3 is equal to 0. And for this one that we have here, two numbers multiply to give a negative 12 and add to give a negative 7. In this particular case, we'll have to use our quadratic formula. Y is equal to negative of negative 7 plus or minus the square root of negative 7 squared minus 4 times a our calculator, and I'm not going to be prepared to do that on this occasion. Alright, so I will therefore discontinue with that one that will give us the horrible irrational values, and I will go no doubt to, hopefully this one does not. We have 3p plus 2r, 3p plus 2r is equal to 7. So 3p plus 2r is equal to 7, and p squared minus 2r is equal to 11. P squared minus 2r is equal to 11. Right. Now, that one, which is the one that we have right here, of course, we can see very quickly that the positive 2r, the negative 2r right there are additive inverses. Therefore, if we add the two equations, what will happen? If we add the two equations, these will be eliminated. And we will have p squared to be added to 3p, and that will be equal to 18, which of course we will not cause to remain on that right hand side because we're going to have a trinomial at any rate. So we are going to have negative 18 is equal to 0. So we'll have the two numbers that multiply to give a positive 18, sorry, a negative 18. These two numbers multiply to give a negative 18, and when we add them, we get a positive 3. So we're going to have p plus 6 with p minus 3. So in this particular case, p is equal to a negative 6 or a positive 3. And that, of course, I think we'll put into this equation. Into equation 1. Now, what we have done here is that we have added equation 1 to equation 2. Seeing that these are additive inverses and will be eliminated by addition, so we added these two. So we have p squared to be added to 3p. We have that here. On the right hand side, we will have 7 plus 11, which is equal to 18, but we decided to transpose. So we have a negative 18 is equal to 0, because we just don't want to waste an additional step just to transpose positive 18 to one side. So p is equal to negative 6 or a positive 3, and that we are going to put in this equation. So 3 times negative 6 plus 2r is equal to 7. So 2r is equal to 7. 3 times is 18 plus 18. So r is equal to 25 over 2 in that case. And what about the other case? 3 times 3 plus, it's not written properly, 3 times 3 plus 2r is equal to 7. So 2r is equal to, this is going to be a 9 and negative 2. So r is equal to negative 1. So when p is equal to negative 6, r is equal to 25 over 2. And when p is equal to 3, like this one. I'm not going to attempt to put it here. I'm going to write that beginning all the way there, number 7. Let's see what that will turn out to be. So we have, for this one, 2x squared plus y squared is equal to 33. 2x squared plus y squared is equal to 33. And x plus y is equal to 3. X plus y is equal to 3. So 2x squared plus y squared is equal to 33. And x plus y is equal to 3. So this is your equation 1. And this is your equation 2. And what I'm going to do is, we're just going to go straight ahead and use what we generally have as the universal method. The universal method in solving this. And the universal method is what? Substitution. From equation 2, which one is better? I think it is better to say y is equal to. Y is equal to 3 minus x. And that is your equation 3. That we are going to put into equation 1. So for equation 1, we have 2x squared plus y squared, y is 3 minus x, that is squared. And that is equal to 33. So, hopefully, we did not make a meal of that, neither by typographical error, nor transcribing the information. So, let us see what we make of this one. So, what we'll have is 2x squared plus 9 minus 6x plus x squared is equal to 33. That's nice. We can see already that the entire equation is a multiple of 3. So we can divide through by the entire equation by 3. Now, some students will think that 3 minus x all squared is hasty. My students know how to just expand a perfect square in one step. The first one squared, 2 times the first times the second, then the second one squared. My students know that. They will not have any difficulty with it. So what do we have now? We have 2x squared plus x squared, so that will give us 3x squared. We are very happy to have that 3x squared there. Then what do we have? Minus 6x, we are also happy to have that negative 6x there. Also, 9 minus 33. That's what we'll have. 9 minus 33. Or, we could do it the other way around. Whenever we subtract, I'm hearing much nice. Whenever we add numbers that have different signs, we subtract the smaller from the larger, and the answer will take the same sign as the larger. So we will have 33 minus 9, and that will give us 24. So that will be a negative 24, and that is equal to 0. Now we see that everything may be divided by 3 all the way through. So we have x squared minus 2x minus 12 is equal to 0. Let me write that again. 3 into 3x squared is x squared. 3 into 6x is negative 2x. And 3 into 24, that's 8. That's your favorite. My students know that trinomial by that in back of the head. So what will we do? Two numbers minus 4, which is negative 1. When x is equal to negative 2, what is y equal to? When x is equal to negative 2, what is y equal to? Put a negative 2 here. 3 minus negative 2 will give you a positive 5 right here. So we did not have to go through another 5 pages in order just to write the answer down. So we'll take this off and hopefully we can put another 2 right there depending on what the circumstance will be. Number 9. Number 9 is a wide one. It says x squared plus xy plus y squared. X squared plus xy plus, I should do that in another color. X squared plus xy plus y squared is equal to I'm looking for it. X squared plus xy plus y is equal to 2x plus 3y is equal to 7. 2x plus 3y is equal to 7. So that is x squared plus xy plus y squared is equal to 2x plus 3y is equal to 7. What it means is that x squared plus xy plus y squared is equal to 7. That's what it means. It also means that 2x plus 3y is equal to 7. That's what it means. Now, I'm looking at this system of equations and I'm looking for something to make it simple and I can't find anything. So, I will go straight ahead and say, this is equation 1. I imagine it's coming all the way down there. And this is equation 2. So I'm going to say, for this one, from equation 2, x is equal to 3y, not 3y, 7 minus 3y all over 2. And that's equation 3. And that's what we're going to put into equation 1. My word. Well, I'm sure that it's going to work out to be quite simple. Here we have x is equal to 7 minus 3y over 2. X is equal to 7 minus 3y over 2. And then we have x squared here. So we're going to have what? 7 minus 3y over 2 all squared. That's nice. Plus xy. What is xy? 7 minus 3y over 2 times y plus y squared. Then all of a sudden that is equal to 7. Now this is what we'll have here for the perfect square. 49 7 3s 21 minus 42y plus 9y squared. So that's what we're going to have there. And then all of that is going to be over 4, just in case. Then plus something over 2. What is that going to be? 7 times y, and then we're going to have minus 3y squared. And then what? Plus y squared minus 7 is equal to 0. So this is quite a bit of expression, and we're going to multiply the entire thing by 4. Multiplying by 4, what will happen? 49 minus 42y plus 9y squared plus, if we're multiplying by 4, the 4 will cancel with this 2, so we'll have a 2 there, so that's going to be 14y minus 6y squared plus 4y squared, because it's times 4 also. Then times this by 4, minus 28 is equal to 0. Now, what will happen? Everything will condense into a simple expression very quickly. Because we're going to have here 9y squared plus 4y squared, that's going to be 13y squared minus 6y squared, so that is going to give us 7y squared. So we're going to have 7y squared. Now, I'm not going to be frightened by the size of the coefficients, because I am seeing where we have the multiples of 7 coming in, and there's a great chance that in the end we may be capable of dividing straight through by 7. So let us put the y's now. Negative 42y with a 14y, and I don't see any more. So it is going to be negative 42y with a 14y. Of course, it's 3 of them, so I think it's going to be 28. Negative 28y. I'm a bit hasty with the calculation, with that calculation. And then what happens next? The numbers. So 49. And then all the way down here we have a negative 28. So that will give you a 21. Three, 4 in the middle and 3. So that's nice. So that will give us a plus 21y. Just 21, and that is equal to 0. And of course, we see very quickly that 7 is a common factor right here. So 7 being a common factor right here, we'll have what? Y minus 4y plus 3 is equal to 0. And all my students know that when the sum is greater than the product, that one of the numbers is 1. So we might write it here. Y minus 1, y minus 3 is equal to 0. So, y is equal to 1 or 3, and we're going to put that into equation 3. We're going to put that into equation 3. And we're not going to be disturbed by it. So let us put that into equation 3 very quickly. We have x is equal to 7 minus 3 times 1 over 2. So x is equal to 7 minus 3 times 1. 7 minus 3 times y is 1. 7 minus 3 times y over 2. 7 minus 3, which is going to be 4, divided by 2, that's going to give you 2. And on the other occasion, we're going to have x is equal to 7 minus 3 times 3 over 2. So x is going to be equal to negative 1, I think, because we're going to have negative 9 here. 7 minus 9, that is going to give us a negative 2 divided by 2 will give us a negative 1. So when x is equal to 2, y is equal to 1. When solution turns out to give very simple numbers. So we are 100% sure that that one was given to us properly. Now, I'm going to march merrily to number 11, because we're always skipping out one, because we're giving the even numbers for students to do for homework. And I'm going to go all the way to that one. X squared over 6 plus y over 4 is equal to 1. X plus y is equal to 5. I'm going to take a look at that one. Let's go. So what do we say? We say x plus, I'm going to go to it, x squared over 6 plus y squared over 4 is equal to 1. That's the equation 1. So x squared over 6 plus y, not y squared, just y over 4. Y over 4 is equal to 1. Meanwhile, x plus y is equal to 5. X plus y is equal to 5, and that is your equation 2. Now, I am looking at that. I'm going to go far away. I'm going to take a look at that and see if there's anything in there that will make the solution simple. So I'm trying to look for what we call a loop of simplicity, something that makes it simple. X squared over 6 plus y over 4 is equal to 1, and x plus y is equal to 5. Well, maybe not. So what will make it simple is that if we don't have to square a binomial. So we could say x is equal to 5 minus y. Let me go back there. We can say x is equal to 5 minus y, but we put 5 minus y here and square it. It's going to give us a more cumbersome expression than if we say y is equal to 5 minus x. So let's go. From 2, y is equal to 5 minus x. That is equation 3, and that we're going to put into equation 1. Because we're not going to be squaring a binomial, so that's going to be easier for us to handle. So we're going to say x squared over 6 plus 5 minus x over 4, and that is equal to 1. And we'll multiply the entire equation by the LCM of 6 and 4, which turns out to be 12. So we're going to multiply the entire equation by 12. Multiplying the entire equation by 12, we will have what? 2x squared there plus 3 here for the 12, 5 minus x, and minus 12 is equal to 0. Because we're going to multiply the 1 by 12 also, and we're going to transpose that to the right, to the left hand side. So what do we have? X squared plus 15 minus 3x minus 12 is equal to 0. X squared minus 3x minus 3 is equal to 0. I am hoping that we made something out of it that should have been a little different, so we're going to take a second look at that. When this does not give rational answers, I'm not going to waste too much time on it, but I'm just going to make sure that look at that. Let's go. From 2, y is equal to 5 minus x. So we're going to have x squared over 6 plus y is 5 minus x, that's going to go over 4. X squared plus, yes, it's plus x squared 4, and it's equal to 1. Right? That is equal to 1, nonetheless. So we're just multiplying by 12. So when we multiply by 12, 6 into 12 is going to be 2. So we have 2x squared plus 4 into 12 is going to be 3. So we're going to have 3 to be multiplied by 5 minus x. And then, of course, 1 times 12 will give us 12. No doubt. So we'll have 2x squared plus 15x minus 3x minus 12 is equal to 0. And this is what we'll have. So we're going to have irrational expressions. So we're going to have x is equal to negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 3, put a 2 this because it looks like 2, all over 2 times 2. This will give us 9. And this will give us, I think, 24. Let's see, 4 2s. Right, that will give us 24. So it's going to be a 9 plus 24. So we're going to have an irrational expression there. And we have quite a bit more to work out. So we're not going to waste time on those that will give us irrational stuff, because we have quite a few for us to work out right here. So we'll go straight ahead to those that will not give us irrational answers. Here we go. Y is equal to 8 minus x. So y is equal to 8 minus x. That's the equation 1. And the other one is 2x squared plus xy is equal to negative 16. 2x squared plus xy, 2x squared plus xy is equal to negative 16, and that is your equation. Surely, this one will not take the entire hour for us to work out, because here we already have y is equal to 8 minus x. So 2x squared plus x. What is y? Y is 8 minus x. 8 minus x. Then we have a negative 16, so we're going to have plus 16 is equal to 0. So, what will we have? 2x squared plus 8x, that's nice, minus x squared plus 16 is equal to 0. So we're going to have 2x squared minus x squared, so that will give us x squared plus 8x plus 16 is equal to 0. And of course, we can see what this is. That is a perfect square. As a matter of fact, this one is merely x plus 4 all squared equals 0. Therefore, x is equal to 4 on both occasions. So x is equal to 4 on both occasions. Or we may say that we have repeated roots, or we have equal roots. will not say that we have one root, because if the equation is quadratic, we should not have one root, we should have two roots, even if the roots are equal. If we don't have different roots, then there's no way they can be equal. But if we don't have separate, that should be the correct thing to say. If we don't have separate roots, then they cannot be equal. Because a single root cannot be equal. So we have equal roots, or what we call repeated roots. So what will be the value of y? Y is equal to 8 minus x. So y is equal to 8 minus 4. So y is equal to 4 also. So y is equal to 4. So let us revisit that. So x is equal to, this being positive will be negative 4 on both occasions, right? X will be negative 4 on both occasions. And what we have here is y is equal to 8 minus x. So y is equal to 8 minus negative 4. So y will be equal to 12 on both occasions. So what it means is that we have repeated roots. Also, what it means is that this curve and this line, they don't cross each other like this. If they cross each other like that, then these points would be different. What happens is that the curve touches the line like that. So instead of crossing like this, it touches like this. This line is called a secant, which some individuals will call a secant. It crosses the curve like that. This line is called a tangent. It does not cross the curve. It touches the curve. And some will say that it touches the curve at a single point. But students, it is for you to learn at this early stage that it cannot touch the curve at a single point. Because if the line touches the curve at a single point, then there is no way that we can find the gradient of the curve. We cannot find the gradient of the curve, if the curve is touched at a single point. So what really happens is that the curve is in contact with the line at 2 points that are so close that the difference between them is insignificant. And you'll learn that when you go more advanced in mathematics. So, of course, the values of x are the same, the values of y are the same. So it turns out that what we identify macroscopically as a single point would be where x is equal to negative 4 and y is equal to 12. We identify that macroscopically as a single point, but we are sure that's not a single point microscopically or in actuality, but 2 points that are so close that the difference between them is insignificant. So do we have any more? Sure. I think that we're going to do 2 more. These are going to be very nice. I'm wondering if I haven't seen this one before. X squared is equal to 4 minus y, and x is equal to y plus 2. I think that I've seen that one before. And I'm going to take a check to see if it is that one. Here it is, the very same problem. Alright. Now, I'm going to take a look at this one. I kind of like it because it looks horrible to begin with. Yes, it looks terrible to begin with. So I like it. And it says that y plus 4x is equal to 27. And xy plus x is equal to 40. And xy plus x is equal to 40. So that's equation 1 and that is equation 2. Yeah, I like it because of the numbers are kind of large and so on. So what I'll do very quickly is say from equation 1, y is equal to 27 minus 4x, and that is equation 3. So from equation 1, y is equal to 27 minus 4x, and that I am going to put into equation 2. So in equation 2, where I see y, I put 27 minus 4x. So I put x first, then I put y, 27 minus 4x. Then I see a positive x there. Then I see is equal to 40, so I transpose. Minus 40 is equal to 0. Right. I like problems with the numbers large and outrageous like that one. So what we'll have here is 27x. That goes first. 27x. Then we have what? Minus 4x squared. I hope that's correct. Minus 4x squared plus x minus 40 is equal to 0. Now, we're going to do two things to this equation. Let's see what we make of it. Maybe I'm taking too long to solve that. We have negative 4x squared plus 28x and I think it's minus 40 equals 0. Of course, we see this as being something that is divisible right through and through by 4. But because the x squared coefficient is negative, we are going to choose to divide that by a negative 4 instead. So we'll have x squared there minus 7x plus 10 is equal to 0, and we're on to it right away. Because right away we see the factors there. X minus 5, x minus 2. So x is equal to 5 or 2, which we'll put into equation 3. And we're going to be cramped for space. X is equal to 5 or 2. And we're going to put that into equation 3, which is this one. Y is equal to 27 minus 4 times 5. 4 times x. 4 5 is 20. So we can see already that y is equal to 7 right there. And of course, y is equal to 27 minus 4 times 3. Not 3, 2. 27 minus 8. So in that case, y is equal to 90. So when x is equal to 5, y is equal to 7. When x is equal to 2, y is equal to 90. Right? It does not turn out to be so bad. When the examiners give you some numbers that look like that, it is because they imagine if you do the right thing, then the solution will be greatly simplified in the long run. So that is why I like to see when the numbers are large, because when the numbers are large, they will have to go simple. So I enjoy solving problems for which the coefficients are large. Yes, we have that one. I'm looking and see which one I should solve. Y is equal to 4 minus 2x, or y is equal to 2x squared minus 3x plus 1. I'm going to do this one and see what we make of it. This is your favorite. It's going to be simple. So you see already. I'm going to see if we can solve this one without actually writing anything. Y is equal to x plus 2. Y is equal to x squared. Now, we know that we have to have two sets of answers for this. And it says that y is equal to x plus 2 and y is equal to x squared. Let's see what we can make of it without actually solving the system. Let's see what we can make of it. Well, we're going to solve it in our minds, but we're not going to be writing much. Y is equal to x plus 2 and y is equal to x squared. Alright. Let's go. Now, y is equal to x plus 2 and y is equal to x squared. I can see immediately that if I put a 2 here, 2 plus 2 is equal to 4 and 2 squared is equal to 4. So we can see that when x is equal to 2, y is equal to 4. Because y is equal to x plus 2. Y is equal to x squared. 2 squared is 4 and 2 plus 2 is 4. So when x is equal to 2, y is equal to 4. If we square 2, we get 4. And if we have 2 plus 2, we'll get 4. So there is no difficulty with that. What about the other one? For the other one, we'll say 1 plus 2 is equal to 3. Then we are going to find ourselves in trouble. equal to 1. But we are not far away. Why? Because let's change it to a negative 1. Negative 1 plus 2 is equal to 1. And negative 1 squared is equal to 1. So when x is equal to negative 1, y is equal to 1. So when x is equal to 2, y is equal to 4. When x is equal to negative 1, y is equal to 1. Because if we put a negative 1 here, negative 1 plus 2 is equal to 1. There. And if we put a negative 1 here, negative 1 squared is equal to 1. So we have it right there. So we did not have to go at length to arrive at that. What I'll do though, I'll just use one method, one simple method in solving the system to show that actually we are correct. So if y is equal to this and y is equal to this, it means that both of them are equal. So x squared is equal to x plus 2. So let's see. X squared is equal to x plus 2. So if we rewrite that, we'll get x squared minus x minus 2 is equal to 0. So x minus 2, x plus 1 is equal to 0. So x is equal to 2 or negative 1. Need I say more? So when x is equal to 2, we see that y is equal to 4. And when x is equal to negative 1, we see that y is equal to 1. So we don't need more proof than that. Well, I saw another one right there, and I'm going to give it a try. It will work itself out. So we will have no worries. Yes, this one that we are going to be taking a look at is going to work itself out. And this is the last one that we'll be taking a look at. Your favorite coming up next. Alright. Now, by the looks of that one, we are going to have a fraction in our answer. So by the look of that one, we are going to be having a fraction. But let's go straight ahead. Let's not worry about it. How will we solve this one? Since y is equal to this and y is equal to this, then we're going to say that this is equal to this. Because both of them are equal to y, therefore both of them must be equal. That's right. And then what will happen next? negative 1. That's nice. 3 over 2 is not too bad. That's where we're going to put into equation 1. Of course, this should have been your equation 1 and this should have been your equation 2. So when we put that into equation 1, what happens? Y is equal to 4 minus 2 times something. 3 over 2. In which case, the 2's will cancel, so 4 minus 3, so y is equal to 1 right there. And then when x is equal to negative 1, y is equal to 4 minus 2 times negative 1. So that's going to be a plus 2. So y is equal to 6. So when x is equal to 3 over 2, y is equal to 1. And then when x is equal to negative 1, y is equal to 6. So somebody's just getting in, and of course we are about to get out. So there we have all, well not all, but our entire tutorial on the solution of a pair of simultaneous equations of which one is a quadratic and one is linear. In solving such a system, the system is always susceptible to substitution, but as we have shown, we have cases in which elimination is possible. So it is not limited to substitution alone, but in some cases we see that one of the unknown may be eliminated, and we might take that approach. As a matter of fact, we should not just go blindly in attempt to solve the problem, but we should analyze the system first in order to see if there is anything that makes it simple. So that should be the final presentation in our algebra. So algebra is closed. So all of my students might watch all of the other visuals in order to have a full revision of your algebra book